Hello and welcome back, and in this video we are going to discuss about the random variables. What is the random variable and what is the probability distribution, a basic idea. Okay, so random variable, how we decide the random variables. Basically there are some variables which can take some value, right? Either it will take 1 or 2 or 3, right? But there are certain variables which cannot take a single value, right? Suppose if I say that when I throw coin, then if I throw a coin three times, if I throw a coin 3 times, then what is the probability of getting a head, right? What is the probability of getting at least one head? What is the probability of getting at least 2 heads? What is the probability of getting all the 3 heads? What is the probability of getting no heads? All these possibilities which are there, these possibilities and their chances are covered or recorded under a variable which is known as a random variable. So random variables are used where the certain value of a variable is not decided, cannot be decided. It is based on some random experiment and some random value could come up. So what random value could come up, whatever are the possible random values are there, those random values are the set for this random variable, right? And those are represented as the values for the random variable. I hope you are now getting an idea about the random variable. Random variables are those variables which takes the value from a random experiment, output of a random experiment. Let me explain you. So first of all, let us take one example. One example is that I want to throw a coin thrice, coin 3 times. I want to throw a coin 3 times. Let me explain you one thing. Throwing a coin 3 times or throwing 3 coins in one go. Throwing 3 coins in one go. Both the things are same, right? If you are throwing one coin 3 times or if you are throwing 3 coins simultaneously, then both the things are same. There is no difference between these two things. So if I throw a coin 3 times, then in that case, what are the possible things? What are the possible values that I can get? And what are those possible values I'm trying to get? The possible values are getting a head. We are just talking about head. I'm not talking about a simple specific thing like 1 head or 2 head or 3 head, all head, 0 head. That is not the thing. We are now moving into talking about the distributions, right? Distributions of all the events, because when you will talk about the distribution, then the distribution will fall under some of the probability, right? Under some set of probability, under some probability for that particular sample set, right? Just like there was a sample set of throwing a die and all the possible values 1, 2, 3, 4, 5, 6, right? So all these possible values, when we distribute this under a curve, their probabilities and the event and the probabilities, when we cover under a certain curve, then this is known as the probability curve, right? This is known as the probability curve, right? So we are moving in that direction. We are moving into the in that direction, in that particular random variable plus the probability curve direction, right? So we are throwing one coin 3 times, right? Now if such kind of event comes, then the formula is you need to see the random experiment, how many times we are doing that experiment, right? Like we are doing here thrice, we are doing it 3 times. So the formula is that the possible values will be 2 raised to the power n. The possibilities of getting the values will be 8. 2 raised to the power 3 is equal to 8. So this is the formula. These are all the possible combinations that you can get. 8 possible combinations are there which you will be able to get when you perform this experiment. Any experiment which takes n number, where there are n number of chances you have taken, then in that case those chances are put here, 2 raised to the power n. N is the value of chances, and then you get the total possible values that you can get, total possibilities, right? So there are 8 possibilities. So how we can get those 8 possibilities? The simple formula is that 2 raised to the power 3 is equal to 8. Do the half of this 8, which is 4. Now do this thing, 4 times h and 4 times t. 4 times h and 4 times t. Now do the half of 4, which becomes 2. So 2 times h and 2 times t. 2 times h and 2 times t. Now half of 2, which is 1. So 1 time h, 1 t, h, t, h, t, h, t. So comma, put the commas, okay, and here like this is the way. Sample space is like this. So this is the sample space, 8 possibilities are there, right? So when you will throw a coin 3 times, then these will be the possibilities, right? You can get head first time, second time as well you can get head, third time you can get head, you can get head on 2, tail on 1, you can get head, tail, head in 3, when you throw it thrice, then the possibility is that first you get head, second you get tail, then third you get again head, then HTT, which means head, tail and tail, then THH, tail, head and head, then THT, tail, head and tail, 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 head, tail, tail, tail. So these are all the possibilities we have covered here, and this is the formula and this is the method that you can find out that how many possibilities are, how many possible values combinations are there. So this is like first time throwing, this is like second time throwing, this is like third time throwing. So this is one possibility when you throw a coin 3 times. This is the second possibility, third, fourth, fifth, sixth, seventh, eighth, right? So there are 8 possibilities. Now let us talk about the random variables, how we choose the value of the random variable. Suppose we are interested in the event of getting head, right? Getting head. This will be our event of interest, and we want to get the distribution of this event, right? We want to get the probability of these, of all the possible head events we are going to take here into consideration. So first case is that you will get 3 here, 3 head. Here I am getting only 2 heads. Here I am getting 2 heads. Here I am getting 1 head. Here I am getting 2 heads. Here I am getting 1 head. Here I am getting 1 head. And here I am getting 0 heads. Okay. So 0 heads, right? And 2 heads, 1 head, and 2 heads and 3 heads. These are the possibilities. So all the possibilities that I can get no head, I can get 1 head, I can get 2 heads, I can get 3 heads. All these possibilities can be taken for the random variable. RV is equal to, what are the possible values? 0 can be there, 1 can be there, 2 can be there, and 3 can be there. 0 times head I am getting, 0 heads I am getting, 1 head I am getting, 2 heads I am getting, and 3 heads I am getting. So all the possibilities for getting head falls under this set of variables, right? 3 times head, 2 times head, 1 times head, and no head at all, right? So this set of values is known as the value for the random variables, or you can say the set for the random variable values, right? Now if we see the the value of the probability of getting head, let me make it a kind of curve, right? So here if you see, here is the value of random variable RV, and here is the probability PRV. Okay, so the values were 0, 1 head, 2 head, and 3 heads. Okay, what are the possibilities? 0 heads, what is the probability? How many times 0 has come? Only 1 time. And what are the total possible combinations? How many number of elements in the sample space? 8. 8 is the sample. It is the number of elements in the sample space, right? And the possibility is possibility that you don't get any head is 0, right? Is 1 time. It's only 1 time coming, right? So we will not get any head. The probability will be 1 by 8 because we have got 0 only once. Similarly, if someone says that probability of getting 1 head, what is the number of 1? We have got 1, 2, and 3. We have get 3 times 1, right? 1 head 3 times we have got. So if someone says that I can get 1 head, what is the probability in this experiment? Then it will become 3 by 8. Getting my point? 3 by 8, because you have 1, 1, 1 3 times. Similarly, if we talk about the 2, that how many times, what is the probability of getting 2 heads in this experiment? Then it will become 3 by 8. Why? Because 2 is also 3 times, 1, 2 and 3. This is also come 3 times. So 3 by 8 now comes to 3. How many times, what is the probability of getting 3 heads when you do this experiment, right? Throwing the coin 3 times. After throwing the coin 3 times, what is the probability of getting all 3 are heads? So the probability is 1 by 8 because you have got 3 only once, right? 3 heads only once, right? So this is known as the probability, this is probability table. This is known as the probability table. Okay, so based on this probability table, right, based on this probability table, we create a curve, right? What happens to that curve? The curve will be, this will be the probability, this axis is the probability and this axis is the random variable value. So random variable values are here, we start from 0, there, then we come like 1 by 8, 2 by, it can be 2 by 8, 3 by 8, 4 by 8, 5 by 8, something like that, right? So when we go to the 0, then it's like 1 by 8, the probability is 1 by 8, somewhere here it finds, right? So here the curve becomes like this. This is 0, getting 0 times is 1 by 8. See, this is, this 0 is there, right? No, not like this. It should be, right, like when 0 is there, then it should be 1 by 8, right, on 0. So this is value, right? So I have written wrong. So this is 1, 2, 3. Let me make it more elaborative. This is 1, this is 2, this is 3. 0, 1, 2, 3. So on 0 it will be 1 by 8 somewhere here. Now let's 1, then when we come to 1, then it comes somewhere here. It's 3 by 8, right? So it becomes like this, right? Then we come to 2, then it becomes like this, right? Then we come to 3, then it becomes, when you go to the 3, then it becomes like this, right? So when you start working on this one, this curve becomes something like this, right? And when you consider this random variable that you will get 0, you can take slightly has a one event, something like that. So it could be, since finding 0 is 1 by 8, right? So here you can, here you need to present this 1 as well, right? 1 by 8 as well. So for 0 you can take 0 somewhere here, right? The random variable value 0, right? You can take it from here, right? So rather than coinciding it with the 0, we are considering a real scenario where this particular particular graph will look like, right? How exactly it will look like. So in that case, taking 0 as here, I'm not taking this as here, I'm taking this as event here 0, which is something like this. And then for the 3 by 8 it will something like this, and for the 2 it will something like this. So it will be created like this, the 4 boxes, something like this. So this is known as the probability distribution curve, and this is known as the binomial distribution curve. Why this is known as the binomial distribution curve, in the coming videos we'll discuss about that. But yeah, here I have taken one event, right, one random variable value, which is 0. I cannot take this as coinciding here because in that case it will be a bit difficult to have this visualizing this shape, right? So that's why I'm showing you in this manner. So these are the possibilities of getting the values, right, of anything to happen. So this is how the probability distribution curves are made using the random variables. I hope you must have understood the random variable and how the distribution curves are created. Now before we conclude this particular video, let me tell you something about the type of random variables. There are two types of random variables. One is discrete random variables, and the second one is continuous random variables. What is the discrete random variable? Discrete random variables are those variables which can only take the values in a complete integer, in a complete number, like 1, 2, 3, 4, 5, 6, just like in the case of throwing a coin and getting head, right? In that experiment we have seen that we got the values in complete number, 1, 0, 1, 2, 3. So when we talk about these kind of variables which can take complete number, then these kind of random variables are known as the discrete random variables. and their charts look like the binomial curve, just we discussed, right? Their chart and their distribution curve looks like that, right? Now we talk about the continuous random variable. Suppose I'm taking one sample, I am taking my city, like I live in Noida. So if I want to take the height of every person, right? I want to take the height of every person. What is the probability that one person should have this height, that height? So in that case, the height cannot be a particular complete number. It will be somewhere like 5.6 feet. It will be somewhere like 7.6 feet. It will be 6.6 feet or 6 feet only, right? So these are the values which are not the complete numbers, right? In that case, between two numbers, see, in case of discrete random variable, between two numbers there is no value. Between 0 and 2 there is nothing. Between 0 and 1 there is nothing. Either 0 or 1 there is nothing. But in case of continuous random variables, in such kind of random experiments where you are trying to find out the height, or you are trying to find out the their average what you say, if you are taking the height, for example, let us take only the height, for example. I don't want to get into much details because it will confuse you. So for the height perspective, if we say someone could be 4.5 feet, someone could be 5.5 feet. So between 4.5 and 5.5, what do you think? How many values can exist? This is a real number, 4.5 and 5.5. These are the real numbers. Between two real numbers, how many numbers could exist? Between 4.5 to 5.5, there can be infinite number of elements which can exist, right? Because 4.5, 5.5 divide 4.5, 5.5 divide by 2, and then whatever value you get, you divide that by 2, you will be able to get infinite number of values between two real numbers. You must have studied about this one as well. Between two real numbers, there are infinite real numbers, right? So when you plot the curve for such kind of things, then you don't get something like these kind of rectangles, right? These kind of things you won't get. You will get a continuous curve, something like this, a continuous curve, something like this, right? It could be something like this, but it will be always continuous. It will not be breaking somewhere, just like the binomial curve that we discussed just before this example. So the continuous random variables are those variables where there are infinite number of values between the two values, and hence that curve looks like a continuous curve, not breaking anywhere, just like unlike the binomial curve. The binomial curve, you saw that there was 1 by 8, there was 3 by 8, then again there was a 3 by 8, right? And then there was again 1 by 8, right? So this is the the binomial curve. There are certain discontinuities, right? From here you see like this one, right? So curve is like this one. But in case of in case of continuous variable, the curve will something look like this. It will be continuous. It will not be creating such kind of areas. It will be creating a particular curved area, right? And that is why that continuous random variable is also really very important in case of data science and machine learning, because most of the events where you will talk about the predictions, those events are basically related to the real world applications, and those are real numbers, right? Means where the two values between the two values there can be number of values, right? So this was all about the random variable introduction. In the next video you will see something new, that how we can plot a curve and what are the probability density functions and what are the probability mass functions. Those we are going to discuss in the next video. So let me tell you: probability distribution function, probability density distribution, and probability mass function, right? Density function and mass function. So these two, what are these two functions? We are going to discuss about that in the next video. Till then, have a nice day and bye bye.